Good afternoon. Welcome to today's Liftoff webinar. My name is Christine Longroy. I'm Senior Director of Ecosystem here at Lift. Thank you for joining us. Today, I'm excited to have Anya Miles from EOS joining us. She's a project engineer in metals. And today we are talking about how EOS Additive Minds Turnkey Solutions and the success the U.S. Navy has had on this solution. So Anya joined EOS North America as the senior project engineer, where she solely focuses on her expertise and qualifications of the additive manufacturing applications. In this current role, as the manager of the metals project engineering team, she leads this team of the senior AM engineers working on large projects such as the Additive Minds Turnkey projects. EOS is responsible for manufacturing solutions via the industrial 3D printed technology to manufacturers around the world, connecting high quality production efficiency with its pioneering innovation and sustainable practices. So I'm thrilled to have Anya present. As a reminder, I'd like to have all the folks ask your questions in the question chat function in the webinar. And we're going to get started today. So thanks again for joining us.
Welcome to Liftoff Webinars, brought to you by LIFT, the National Advanced Material Manufacturing Innovation Institute, where we drive American manufacturing into the future through technology and talent development. LIFT is a public-private partnership where we convene and connect government, industry, and academia in the fields of advanced materials, manufacturing processes, systems engineering to enhance America's manufacturing competitiveness, national economy, and national security.
Hello and welcome to my webinar today. The title of the talk is Strengthening Manufacturing Industrial Base, Additive Minds Turnkey Solutions for Supplier Enablement. So let's see what hides behind this long title. First, I would like to go over the content of my presentation. And I will start with a brief introduction of myself and the team, and then dive right into the definition of the term turnkey project, the way we use it in the Additive Minds team, and then follow up with a success story of one of our largest turnkey projects with the United States Navy. And then we will have some time to go over questions and answers. So first, the introduction. My name is Anya Miles. I'm the team manager of the project engineering team here at EOS in North America. And if you want to reach out to me, you can contact me via phone or the email address shown here on the slide. And let me know if you have any questions, even after the talk. I will be always interested to hear them and make myself available for calls or respond via email. As I already said, I'm part of the Additive Minds team here in North America. It's a group of engineers, applied engineering team. It's a group of people that have a lot of experience with Additive Minds. Most of us have 5+ years. Some of us have even more than 10 years experience with additive manufacturing. And the picture you see here is only the North American part of the global team. We also have another part of the team is located in Germany, and another team is in in APAC region. So globally, we have over 100 engineers working together and helping the industry and our customers adapting the technology, learning, and using it for their real-life applications. And now I want to just first show you a couple of the topics that we can support with and that we are trained and experts in. So we have a group within the Additive Minds team that is called the Additive Minds Academy, which can provide training on all aspects of additive manufacturing. So this group is specialized in e-learnings, but also provides hands-on operation trainings So really starting from, potentially only a 30-minute e-learning all the way to 2 weeks of hands-on training in person with one of our trainers. There are different learning paths that can be optimized according to the needs of any person that is interested in going through training with us. And yeah, the team is very experienced and records new trainings every day. One other thing we can help with is factory design and layout planning for customers that are interested in bringing new equipment on site. Our engineers have a lot of experience optimizing for everyday real-life production situation, considering not only our machines and the best way to work around them, but also any other equipment that is very helpful and useful, like blenders or depowdering units, as part of the complete package of layout planning and design. Another point that has been very important over the last years, now that we're not only looking at prototyping and that is the only use of additive manufacturing, but now we're also looking at real applications and business case, the return of investment when a customer or company is interested in purchasing our equipment for the first time, and making sure that they can get the best value and they're choosing the right type of system and the right application that is really optimized for additive manufacturing. In certain situations, customers approach us and say that they want to use a material that we might not have yet. So that is something we have an R&D team as part of our North American Additive Minds team that works, is well connected with our teams, other R&D teams in Germany and in Finland, and they can develop new materials and processes based on really the needs of a company and an application. So that's very helpful to have the guidance and the expertise on the team, and many of our customers have taken that approach and developed new materials and processes together with us. Not only the development of new materials, but also the design or redesign of parts for additive manufacturing is one of the most important things. And I think it's something that's very important to our team, and it's always very exciting to work with real parts and real customer applications and make sure that they get to utilize additive manufacturing and all its freedom and complexity to the maximum. So redesign of any type of part or component is, I would say, a key part of our work, of our day-to-day work. And then also with every manufacturing process nowadays, a lot of data is usually collected and can be used to optimize the process and also the utilization of the equipment. So that is also something we offer, the guidance on how to collect the right data and then how to either write algorithms to do some analysis or use our plugins and software to get the information that's really important to make the right decisions on production and utilization. Another thing that has become more and more important over the years is the qualification of our equipment. So in the beginning, when I started 9 years ago, there was pretty much no guidance on how to qualify AM equipment because there were no standards and it was more still in a prototyping world. But nowadays we have a lot of standards available and we are familiar with them, and we can provide guidance on how to be compliant with those standards and how to implement certain work instructions or ways to measure certain characteristics of the machines to be compliant with those standards. And then the last point that I have listed here is production optimization and scalability, which is also something that we've seen become more important over the years since, as I said in the beginning, it was all about prototyping, but now we're really looking at full-blown manufacturing and utilizing the technology for a high level part production. And yeah, that's something that can be challenging. And our team is already, even when the customer is only interested in purchasing one piece of equipment in the beginning, thinking about how to scale their business case, and we're helping to set them up right for success in the beginning of every product and every engagement. All right, then moving on to my definition of a turnkey project. I think most of us have heard the term turnkey before, maybe when thinking about purchasing a house. That makes probably the most sense to think of a turnkey setup here, and we just tell one key person all our wish list and what all we want for them to consider, and then they take it and run and hand us a key in the end of the project, and we just pay the bill and that's it. For us in the Additive Minds world, a turnkey project is similar, but one thing that is worth pointing out is that most of our turnkey projects start with a certain challenge. So what we've seen in the past is that they're especially relevant and interesting for customers that do not have either their facility ready to move in a new piece of equipment, or have no experience with additive manufacturing so far and just need some help from experts to get started. So in the beginning of a turnkey project, pretty much like any other project, we would sit together, have a kickoff meeting, and discuss the scope of the work to make sure that we have a clearly defined a list of deliverables and a clear project timeline. And all of this is highly customizable. So every turnkey project that I have been part of has been very, very different than any project that we've done before. And that's perfectly fine. Every customer situation is different, and every timeline and the needs of every customer are different. So we are fully capable of customizing all these projects to make it worth the customer's time or the company's time, and then work together on the details. It usually involves either an equipment purchase or renting one of our machines. So renting machine time for example, a couple months, but up to a year. But usually, as I said, there's some limitation on the company side to bringing in equipment into their facility. So usually they purchase equipment and then we install it on site and run it for them. We have a technical center here in Austin, Texas, and this is where we have delegated turnkey rooms. You can see that in the bottom right picture here. These turnkey bays are different size. So one of them is pretty large and can fit 2 M400 systems. The other 2 are smaller and could fit a 290, a 300, or an M400. And they are access controlled and have everything inside the room or space for everything that we would need to run each individual machine. So ITAR compliance and the privacy of each customer is important to us and is not a problem. It's given in our current setup. And currently we have 2 of our turnkey rooms filled with the third one. The customer has just moved out, so we have space to welcome new turnkey projects. And even if we run out of space in this facility, we can also expand to another location. Then when it comes to the execution of a turnkey project, project management is in our hands, but we will always try to keep a very open communication line to the customer. So we have multiple internal and external meetings for every turnkey project every week, and the virtual team can work closely together to make sure that deliverables and timeline stays on track. And our engineers, not only do we take care of the project management, but we also help with any type of build, setup, machine operation, and we have our service team local to our office. So if anything happens, we can all get together and get the situation resolved and keep running the machine to ensure a smooth project deliverable. As I already mentioned, ITAR compliance is sometimes very important. Even if it's not on that level, customer privacy is important to us to make sure that every turnkey room stays closed and to itself. If a customer decides to come on site and run their own machine, that's not a problem. We can welcome any customer and any engineer or team from the customer to our facility and even provide meeting rooms and workspace outside of the turnkey room. So now I would like to highlight some of the big benefits that I see after working on multiple turnkey projects now. It can really help to kickstart additive manufacturing at a company that has no experience. So not only does it help to shorten the project timeline, but also the time to market for the product that the company is working on, which is a huge benefit. In our situation, we can, once we have the machine and the project on site, we can make sure that we execute activities in an overlapping way. So while we plan the project and execute the work, the customer can go through e-learnings and at the same time learn from us how we set up their builds, how we plan for their post-processing of their parts, and how machine operation works in general. This is one thing that has been wonderful and really helpful for all the people that have gone through a turnkey project, because it's not only an e-learning, a generic e-learning, but it's really hands-on their parts and their machine. It also eases the operation side of things, because there's a single point of accountability, which is the project manager for the turnkey project, and the customer can reach out to that person with any question or any problem that they might see, and this person will handle it all, provide a solution or an answer. It doesn't matter if it's from the service side or from the application side, or sometimes maybe even going back to the development team in Germany. It's just one person that will provide the answer. There's also the big benefit of achieving high quality parts from the beginning, because the project and the machine is run by experts, and you don't have to worry as a customer about the beginner's mistakes that will happen with the adoption of any new technology. And that's just helpful, not having to worry about bringing in new equipment and having to plan for a certain ramp up time. But in this case, you can start in theory as a customer with your aerospace part production in-house at EOS. Also, it's very efficient. You can either purchase or lease a machine as a customer and then place it with us, the experts, and we will go through the fully customizable project scope together. And when the time comes to relocate the machine, we will hand over not only the machine, but all the learnings as well. Reducing the risk is also one big factor for a turnkey project. Again, the design and the execution, the management and the handover of the project is all done by us. So this is helpful when it comes to unexperienced people, but even people with experience in additive manufacturing appreciate this risk reduction. And then the last bullet point I have listed here is building trust in the technology, the process, and the ecosystem, which has also been proven throughout the last couple turnkey projects that I've worked on, that it's just very helpful to have this counterpart and this point of accountability that can explain the details of the process and ensure that things are done by the book, by our OEM's requirements and recommendations. So yeah, Now, looking at a potential, this is really a high-level overview of how the milestones of a turnkey project could be structured. Of course, in certain turnkey projects, we would have certain phases take much longer than others, but here it's just over time. We would start with the planning of a turnkey project. We gather the requirements, sit down together, create a Gantt chart and milestones, talk about the scope and the timeline really in the very beginning. Usually, as I said, turnkey projects mostly start because of certain limitations at the customer side. If it's anything related to construction, we understand that things can get delayed and certain phases of the project might have to be pushed out or take longer. That's not a problem, but in theory, we would like to keep the turnkey project timeline somewhere between 3 to 12 months. Just based on our experience, it's hard to plan for anything longer than 12 months because we never really know how the requirements or the situation at the customer will change. So the initial scope, we try to keep it short and really just fill in that gap until the customer is ready to welcome their equipment on site and run it themselves. That's part of the planning phase. Then we dive right into the education. We look at the customizable learning paths and then hands-on operations training, which usually happens on the customer's equipment. Then we look at the application or the parts that they're trying to produce and decide if there's any need or use for redesign of the component or new design, which is also part of an education path. And then we just talk about the process itself, if there's any need for certain post-processing, special requirements on the part, if there's any special testing that's required for those parts. And once all that is handled, we can jump into the execution. Sometimes, as I said, those phases can already start in an overlapping way. And our engineers can already start redesigning components while the customer is still learning about the rules of additive manufacturing. And then we run the builds for them. We go, if required, go through qualification and validation of the process. And then if it's part of the project, also coordinate testing and analysis of the part. Once all the execution work of the project is done, we move on to the last step, which is the handover at the closure of the project. We relocate the machine. Our service team will break it down and move it to the customer side, to the final location. We report all the work that has been done at EOS and prepare a documentation package, which can also include some of our process control documents. And we set up a knowledge transfer to ensure that nothing gets lost and all the value moves right over to the customer and they can take it and run and keep producing their parts. Here's a little comparison between a conventional and a turnkey project. When it comes to timeline, I mentioned it a couple times now, there is the huge benefit that things can be done in an overlapping way, but also just in general shortened. So as you can see here, planning and education can happen at the same time. Execution can start a little sooner and can also be shorter just because it's done by experts and there's not this initial learning curve required. So key benefit of any turnkey project is just shortened time to production. Now, after talking about the theory of a turnkey project, I would love to go into the details of the biggest ones that we've done so far, which is our project with the United States Navy. It started out with a turnkey portion, but wasn't only that. So in the end of 2022, the NAVC team and some shipyards and Phillips Federal reached out to us and introduced us to the group and told us that the US Navy is in the process of evaluating laser powder bed fusion as a new manufacturing method to help with supply chain pressure of the traditional manufacturing methods, and in order to be able to meet their goal of 2+1 Columbia and Virginia class submarine platforms. So that was a big scope, and we are very proud to say that we were able to support the US Navy in such an impactful project. So when they first approached us with the scope, we had to break it down and make it a little bit more manageable because it was a huge task to take on. And here's the timeline, a little overview of how things were structured and are still ongoing. So in the very first step, we were looking at a demonstrator facility and situation where we could just prove to the US Navy that it is possible to produce their parts according to their qualification needs on our machines. So we went through the initial qualification and the manufacturing process of the first 4 parts, including a technical data package. I will explain a little bit more what that means, but it's really just a summary of all the steps and information needed to produce submarine parts. So that happened in spring 2023. And the next step was in the summertime to go from the first 4 parts to the next 25 parts that were still produced on our machine. And then in October 2023, their facility was ready to welcome their machine and 2 more machines. So they had a total of 2 M400-1s and 1 M290 installed and qualified at their Center of Excellence in Danville. And they were able to go into larger scale part production and TDP development. The goal for this year, 2024, was to take those TDPs and make them available to service providers that went through the process of the qualification in accordance to the NAVC requirements and their tech pub for additive manufacturing, and start, after going through the qualification process, to dive into part production. Big scale picture for the near future is to have a platform established where contract manufacturers and service providers can go in, see what parts are needed, place their bid, and then get selected for this part production after being qualified. So really what it comes down to here is being able to produce parts for the US Navy anywhere in the United States, bringing manufacturing back to the US and helping with all the challenges they have been facing due to the increased needs to meet their mission goal of 2+1. As I said, the beginning of the project started out as a turnkey project since they weren't ready, their facility wasn't ready yet. So here's just a quick overview of the key facts of this turnkey portion of the project. We had their machine installed here at EOS in Austin, Texas. They had a very, very tight timeline to demonstrate the value of AM to the Navy in the beginning of 2023. So we really only had 3 months time to go through the initial qualification and the part production, which is incredibly hard and tricky timeline considering that there's testing, machining, and post-processing involved in every one of these builds. So something that has to be done by an expert and cannot really be given to someone who's completely new to additive manufacturing. Also, they didn't have any engineers or operators who were trained or experienced enough to perform this scope of work. The scope of work included also a process transfer. So we had the material of choice, 316L, available on our M400 platform, but not the single field. So we had to transfer the process, then go through the initial machine qualification in accordance with the powder bed fusion tech pub, and then develop the first 4 additive manufacturing technical data packages ever. We did everything from part orientation, support generation, and then handing over that information to the right people to create the official technical data package, which is just a PDF document with all the information. We delivered the first 4 fully post-processed parts so they could be tested. And then we also were tasked with the material and process development for a new material to us at EOS, which is copper nickel, and it's a material that's in high demand for the Navy. In the next step, again, remembering the big picture, way the project is designed to scale, we also supported the submarine industrial base activation. So we took all the work that was done at EOS and packaged it in a playbook and made that available to SIP activation partners, service providers that were interested in producing parts for the Navy, and went through the whole qualification process together with them to make it as efficient and fast as possible. The biggest challenges of the project were the amount of stakeholders. There were many, many people from many, many different groups involved, and the communication channels weren't always that clear and easy to follow. So it took some time in the beginning just to get in touch with the right people, find the right information to go through this initial qualification, but then also the part production. And then really the project delivery timeline was one of the other biggest challenges, because it was really only 3 months to get all this work done. Here's just an overview of some of the work that has been done, all the parts that we produced, ITAR parts and cannot be shared. So here's just one picture of on one of the qualification builds with different test coupons on it. An overview of the Gantt chart that kept just growing and getting more complicated. And then the documents that we created for the qualification, we had a process control plan, a quality assurance plan, and just a procedure of how to follow the TechPub guidance. Then we did all the testing and analysis for the project and reviewed the data together with NAVC on a pretty frequent basis. Everything worked out great, and now I just wanted to give a little bit of an insight what the technical data package, the delivery outcome of this initial first 4 TDPs part production project was. So a technical data package is a precise and comprehensive package of information which includes the CAD data of a part. There are fancy ways to embed CAD data in a PDF. So when reviewing the technical data package, you can spin around the part and zoom in and out and really see all the details of the part. It also includes information on the material that is used for this technical data package. Sometimes parts can come in different materials, so it can happen that one specific part has a list of materials that can be chosen from, and depending on the need, the person who would place the order would just reference to one material on the technical data package, and then whoever performs the work knows what to do. It also includes the print process parameters and support structures. It has information on the quality control and the applicable standards for this part, any post-processing, the version control, of course, and the traceability. There's an approver of the TDP, creator and approver. It has a company name. Usually those parts are owned by companies. and a part number and the name of the part itself. And really what the technical data package is and does, it helps to improve the communication across the whole entire supply chain. And it's just a summary of how to produce the part in a way that it's repeatable and easy to hand over to anyone who's qualified on that type of machine and in that material. So after going through the exercise of initial qualification of our system and creating all these documents for the qualification and then part production, we bundled all that information in a playbook for the supplier activation and have gone through the exercise of performing this playbook, executing that playbook now a handful of times. So in the first phase, it always comes down to reviewing the requirements of the NAVC Tech Pub to ensure that the qualification requirements, specs, and acceptance criteria are known at the customer side and up to date based on what the Navy is doing. And then in the second phase, the generic process qualification happens, which is called in this case procedure qualification. So we're just running in a certain material, a certain number of coupons over at least 3 different builds, and then create the documentation and perform the testing and reporting for those. And then once all this work has been done, it goes into a submittal letter, a qualification package, gets reviewed by NAVC, and they will provide feedback and approve it eventually. And once that has happened, the company is ready to go into TDP part production. And yeah, the Navy can just order parts from them. So this playbook has been very helpful and based on all our internal work during our turnkey project. The other thing I would like to highlight here, as it was critical to the work with the Navy, was the development of a new material, which is copper nickel. It has a good corrosion resistance in salt water, and it has a good performance in very low temperatures. Also, it had a very stable processability, which was very helpful for the short timeline we had to develop the material and the process. And the typical applications are pumps and impellers and marine applications. The Navy has a pretty good list of parts that they need to produce in copper nickel. Conventional manufacturing methods are just a little slow. Sorry. Conventional manufacturing methods just didn't work in every case for this material. Supply chain delays and pressure on getting the parts actually on the submarine and not rejected were high. So there was a clear need for additive manufacturing to help out with all these concerns. When we first start with the development of a new material, it starts with a technology readiness level 1, which is just the research of the material. Can it be processed? Can it be atomized? Is it available in a powder form? What are the powder specifications and who can supply the material? So that's what we did, where we started in March of 2023. We found a supplier and were able to run the first builds, saw that it was very much processable. We had a good solution for an initial parameter set, and we're able to do the first tests by May. And then in September, we had a process for in-skin, down-skin, up-skin, contours, and we're able to test the first geometries of similar applications than what the Navy was looking at. We tested the part and the process, and we're happy with it, and moved on to technology readiness level 4, So we had a product that we were able to release in October, where we still did some further optimizations just for powder process heat treatment, testing of the process itself. And currently we have a release process that has gone through initial verification. So we built test coupons across the entire build area, tested them, and were able to deliver the requirements that were needed to go into part production for the Navy. The process is not only released for the Navy, it was developed for them, but it's available to all our customers. So there was a press release, and we have a data sheet for copper nickel now. And all that was done in less than a year. So just to share some feedback from the groups that we've been working with, they were very happy with our team's performance and the help we were able to provide. And they said that the Additive Minds team was a game changer. Our team was willing to take on the impossible challenge of creating 4 qualified parts in 3 months. We were willing to accelerate the delivery, support, install, and the production and coordinate outsourcing of the heat treat and testing. The purchase order for the machine was placed back in November 2022. And the machine was installed in December and ran uninterrupted for almost 2 months as required to meet the deadline. Overall, we're still working together with the Navy on the same project. Now it's not a turnkey setup anymore because they were able to welcome the machine to their facility in October 2023. But now we're just in the advising position and still producing parts for them and test coupons on a regular basis. So the collaboration is still ongoing, but it has been a very big and impactful project that we are very proud to be part of. So now, thank you for your attention, and we have some time for questions and answers.
Thank you for joining Liftoff Webinars, where we propel American manufacturing into the future. Stay tuned for more informative webinars that have the power to shape tomorrow's manufacturing landscape. Discover more about LIFT, our groundbreaking projects, and membership opportunities at lift.technology.
Anya, thank you. What a great presentation. Incredible information that you shared about EOS and your Additive Minds game-changing team. Super important. Are you ready to get started with questions?
Yeah, thank you, Christine.
Excellent. So, you know, a lot of what you shared is really important to the industry. You know, accelerating delivery, risk reduction, building trust, you know, overlapping, you know, on the planning and the execution. It's really important and probably obviously very valuable to the industry and to the Navy. So thanks for sharing those specific wins for you and meeting requirements. NAVC requirements is a big deal. So thanks for sharing that with us today. So I'm going to get started with some of the questions. So can you tell me, you talked about the timeline in some of the, you know, what you presented today, but how long are the turnkey projects typically, and what happens at the end? It's kind of a 2-for-1 question, but can you take that away?
Yeah, thank you. Thank you for the question. Sure. So yeah, I've mentioned it during my talk that usually we're looking at timelines 3 to 12 months. We really don't want to keep it less than 3 months because it just takes some time to get the machine installed and onboarded. So it doesn't really make sense to do it for a project scope that is less than those 3 months. And we usually aim to have the project completed by roughly the 1 year mark. We've done projects in the past that have gone far beyond that timeline, but it just becomes really tricky for us to plan ahead for, you know, that kind of a time frame and really scope it out easily. So what we've done, as I mentioned, sometimes facility topics happen and the time frame just needs to be pushed out a little bit. That's not a problem. We can usually extend the project. So the initial scope would be somewhere, like I mentioned, 3 to 12 months, and then if needed, we can add to that. And then the second part of your question, what happens in the end? So when the scope of the project is completed, we get ready to move the machine to the customer side, and we bundle up all the information that was generated during the time that we worked on the system and on the project, to hand over all the learnings and all the data and really help the owner of the machine to get started without any delays, to just really continue where we stopped and take it from there.
Excellent. Well, having no delays is really important. And, you know, 1 year, we know time flies. Right? So thanks for explaining that and giving us some detail on that. So this is actually a pretty important question as well. How long does it typically take, again, here's a timeline question, to develop a new material and process? So another 2-for-1 question.
Mm-hmm. Yeah, that's an interesting question. And as so often with additive manufacturing, the answer is it depends a little bit. So when there is a request for a new material and a new process, we first have to look at the supply chain and ensure that we can source the material in powder form, with the requirements that we need to process it really on our machines, and then also ensure that there is a reliable supply chain setup that can supply us with the amount of powder that we will need for the project at least, and then also for the future. So when that's the case and it's given, the process development can be done within 6 months, I would say, maybe less. It really comes down to the level of the process that is requested. So if we have to, generate a certain amount of data to sustain the repeatability of the process and demonstrate the certain part performance, or that we can meet certain part properties, then it can take a little longer. If it's really just like, can you process the material in your machine, then it can be a pretty quick thing, and we can just build some bars and cubes and make sure that it's possible to process it. And yeah, so a lot to consider, but overall I would say, like, usually it's like 6 months to probably a year, depending really on all the requirements and the surrounding setup.
That's, again, great detailed information. And I think the important part of that is the reliability and the repeatability of it, and the importance of that. So, and then obviously having the reliable supply chain. So as you said and shared in your presentation, it's the ecosystem that actually, right, comes together to actually deliver that end part or product. So I have another question here. So this is a biggie. For those that are on the audience or in the audience and want to become a supplier to the Navy, this is, how can I become an additive manufacturing part supplier to the Navy? What did you learn through this? What can you share, and how can they get involved?
Yeah, that's like you said, a big question. So overall, the easy answer is to follow the guidance provided by the NAVSEA Tech Pub for laser powder bed fusion. It kind of lays out all the data that they want to see from a supplier to demonstrate that you have the quality management system in place and all the procedures to have a repeatable process. You have a powder handling plan, and you know how to run your machine, and then provide a data set of a number of builds. Like I mentioned, we ran 3 builds to collect data points for different coupon types, and then just show that you meet the requirements that they have in their PPD document for the material that you're looking at. The tech pub, it's not a huge document, but it can take a minute to get familiar with it. So if that sounds like a challenging task and you feel like you need some more guidance and a hand that's holding a hand to hold and guide you through the process, then you can reach out to me and I can provide a lot more insight and also connect you with the right people.
That's very helpful. Thank you. Well, that wraps up the questions that we have today. Obviously, Anya, you did an incredible job. Thanks for sharing that. You shared your contact information. For those still on line, this presentation will be shared following this presentation. I wanted to remind everybody that the next liftoff webinar is going to be January 15th with LIFT's very own Tony Bromwell, the VP of Development, who's going to be talking about our custom alloy classes and feedstock tailored to meet your needs. So this is LIFT's Advanced Metallic Production and Processing Center, which we call AMP. So please mark your calendars to join us on January 15th. Anya, I'd like to thank you for the great presentation today and the very important information about accelerating additive to the industrial manufacturing market. I'd like to thank everybody for joining us today. Have a wonderful week. Thanks again. Bye-bye.
Thank you. Bye.